we're looking at maximum flow, and we're going to look at two methods for finding the maximum flow and how to use those methods to find which edge should we increase. This question is from the 2021 Northern Hemisphere VCAA exam. For this method, finding the zeros, we just start somewhere and we look at one of the paths going from source to sink. I can see that the 5 is the minimum capacity along that path. So I'm going to subtract 5 from all of those numbers. Now, whenever I do a subtraction, I'm going to write down that number there because we have to add all of those up in order to find the maximum flow. My next step is, well, I can no longer go on that path. It's 0. There is no capacity left. Let's look at another path. Let's look at this one, 22 and 8. 8 is the minimum. So let's subtract 8 from both of those numbers. Notice how I'm using different colours. That becomes important a little bit later on. Remember to record down your numbers. Okay, so we can't go along here anymore, and maybe let's just highlight it here so we're really aware of where the zeros are. We're going to go on another path. Let's still use the 14, but this time we'll go down over here. So here, 9 is the lowest. Let's subtract 9 from everything. Okay, so there's no point in going along this path here because I have no options. I can't go on those zeros. So I'm going to go down on the 12. Now along this path, 12 and 5. 5 is the lowest, so let's subtract 5 from everything. And I'll jot that down. Okay, let's keep going. We can't go anywhere going on that path, so let's go down to the 20, and there's no point in going up, so we'll do 20 and the 27. So our last subtraction here, let's subtract 20 from both of these. Okay, I'm going to highlight all those zeros. So our max flow is going to be all of those numbers added up. That's going to be 47. So max flow is 47. Now, after you've done this zero method, you can still find the minimum cut. And we do that by finding a cut that passes through only zeros. It doesn't have to pass through all the zeros, but it can't pass through any non-zero numbers. So getting past that first one, well, obviously I'm going to go through this. So this one next. If I go through that 0, I can't actually go anywhere. So I'm not going to go through the pink 0. Let's go instead over here. I can't pass through that bottom line, so I'm going to go backwards through here. And that's allowed because the 10 edge is going in the wrong direction. It's not included in this cut. So that's actually our cut. And I found it by going through zeros. Let's look at question B. Which edge do I increase by 8 in order to increase the maximum flow by 8? Now we can do this using these zeros here. But this is where the colour comes into play. We want to choose one of the 0 edges to increase, but it's only worth increasing by 8 if the other numbers of that same colour are at least 8. So let's look at this top one. Suppose I increase this by 8. Well, 9 can handle an extra 8, but the 7 can't handle an extra 8. So if I increase that 0 by 8, it will be able to get through that 9 path, but it won't be able to get through the 7. The 7 is the limiting capacity of this full path. So there's no point increasing that by 8. Looking at the second path here, the green one, if I increase that 0 by 8, I'm looking at the 14 because that's also green. Yes, 8 can fit through this 14. So I can see that this is going to be the one that I increase. So that's going to be HK to L is the path that I increase. So now we're going to look at the minimum cut method for finding the max flow and increasing an edge. So here we're going to choose some cuts. We're going to add up the edges that the cut goes through, but just be careful, we're only including edges that go from source to sink. If it's going the opposite direction, we don't include those edges. Okay, so that first one is 59. We can do another one over here. Let's go through the 5 and let's go here. So that's 54. I'm not going to bother going through the 14 or 12 because the 5 is by far the best option of those top 3. So let's keep going through the 5, but this time let's do that. That adds up to 54. Okay, we can do one right on the edge here. That adds up to 61. And there is another cut here that is lower than 54. It turns out to be this sneaky one in here, and that adds up to 47. Now, why does that one work? Well, this 10 isn't included because it's going in the wrong direction. So it's a way to reduce the total number if you can go through those backward arrows. Okay, so we've got our minimum cut. Our max flow is 47. Now let's use these cuts to figure out which edge should we increase by 8 in order to increase that max flow by 8. Now, if it's increasing by 8, then we need to do 47 plus 8. That's going to be 55. So any edge that we increase by 8 has to be through the minimum cut. Has to be one of these edges here. But it also has to increase these two because 55 has to be the lowest cut. So I can pretty easily see that 8, that's the edge that all of those 3 cuts go through. So that's the edge that I have to increase by 8. So HK to L, which is the same answer we got in the previous method.